It is time for 11.1. We're going to be dealing with polynomials. How do you know if something is a polynomial? Well, we have a variable like x to a whole number. Okay, so what is not a polynomial? Something like 2x to the 1.5 or 5x squared minus 6x to the 1/2. You are not allowed to have decimals in the exponent or fractions in the exponent. You're also not allowed to have negatives in the exponents, which is really just 1 over x. So you can't divide by variable. You can't have any exponent that is not a whole number. X to the 0 actually works because that's just 1. Okay. So a polynomial could have multiple terms, like a quadratic has x squared minus 6x plus 4. So this would be a trinomial because it has 3 terms. Okay. So we're going to be manipulating these. We'll start out using the distributive property. This should be pretty easy. 14c to the 4th minus 10c to the 6th. Easy enough, hopefully. All right. So here I have a trinomial minus a trinomial plus another trinomial. So there are a couple different ways to do this. I recommend distributing that in. So negative 5y squared minus 5y plus 5, and then plus 4y squared minus 4y plus 6 plus 8y squared plus 5y plus 5. And now we just combine like terms. Those are like terms. Negative 5 plus 4 is negative 1 plus 8 is 7y squared. And then this one, and this one are like terms. Negative 5 minus 4 is negative 9, plus 5 is negative 4, y. And then our constants, 5, 6, and 5. 5 plus 6 is 11, plus 5 is 16. If you don't want to write it all out that way, you can still do this, but that negative, that minus, might cause you some problems. So it's negative 5 minus negative 4, so that's a plus, and then plus 8. So negative 5 plus 4 is negative 1 plus 8 would be 7y squared. And then you would just follow that same pattern for all of them. Okay, same idea here. So 6x squared y. If I look in the other polynomial, do I have an x squared y? No. So that one has no like terms. So it just stays 6x squared y. What about x squareds? Yes, there is an x squared there, and it's actually a negative 2x squared. So x squared minus 2x squared is negative x squared. Okay, what about x squared y? Do I have another one of those? Yes, right here. So that's negative 3x squared y minus 7x squared y, which would be negative 10. Sorry, not x squared, xy squared. And then this one does not have a like term. It is a negative 5, but it's housed underneath that subtraction. So it would be plus 5y. All right. So here we have a polynomial. The degree is the value of the largest exponent. So in this case, the degree is 8. The leading coefficient is the number in front of the variable that has the largest exponent. And that is a 10. So degree is 8 and leading coefficient is 10. So if I had 5x squared minus 6x to the fourth plus 3x to the third, what is the degree? The degree would be the largest exponent, which is 4, and the leading coefficient is the number in front of the largest exponent. So the leading coefficient is negative 6. Why do we care? Well, the degree tells us the basic shape of this function if we graph it. So if the degree is 2, all degree 2 polynomials look relatively the same. All degree 3 polynomials look relatively the same. All degree 4 polynomials look relatively the same. And then the leading coefficient tells us the direction that this graph is going to be traveling in, and it also sort of tells us how tall or how short it is. So when you're graphing polynomials, the degree and the leading coefficient are very important to know when you're doing the graph. Okay? All right. Here we have to think about what happens when we add those together. So natural numbers, we denote like that, are the numbers 1, 2, 3, and so on. The whole numbers are the numbers 0, 1, 2, 3. The integers are the negatives and the positives of the whole number list. And then I guess all we need is integers. So when we take a number in this list and we subtract another number in that list, do we get a number in the list? So if we take any integer and we subtract any other integer, is it a guarantee that the new number will also be in the integer list? So what would not be an integer? The rational numbers are fractions. Okay. Is there any way to take an integer and subtract an integer and get a fraction? No. So we would say this is always true. Okay. And in mathematical terms, that is called closure. We say the integers are closed under subtraction. If you take an integer and subtract another integer, then you're going to get a number that's also an integer. Okay. Species are closed under regular reproduction. If you take a lizard and you breed it with another lizard, do you get a lizard? Yes. So if you take any animal and breed it with another animal like itself, you're going to get an animal that is the same in the same species. So that would be considered closed. Okay. If you had a horse and you bred it with a horse and you ended up with a cat, that would not be closed. But that doesn't happen. At least I've never seen it happen. Okay. What about an integer added to an integer? If I take a number in that list and I add it to another number in the list, will that always be a number that's in the list? Yes. So that is always. What if you take an integer and you divide it by an integer? Is that always an integer? No. Can you think of an example where that's not true? Well, if I took the number 4 and I divided it by the number -7, is this part of the integer list? No, it's not. So, does it work sometimes or never? Is it possible to take an integer and divide by an integer and get an integer? Yeah, 4 divided by 2 is 2. That's in the list. So it works sometimes, but it doesn't always work. So this would be sometimes. Now we're going to do the same thing with polynomials. If I take a polynomial and I subtract a polynomial, so let's say I had 5x to the third minus 4x plus 2, and I subtract 2x squared minus 3x, is that a polynomial? Well, the only thing we're not allowed to do in a polynomial is something to a fraction, something to a decimal, something to a negative number, or this is equivalent to 1 over x to the third. Will this break any of those rules? No. Every time you take a polynomial and you subtract a polynomial, you get a polynomial. Okay? All right, what if we multiply? So let's change this to a multiply. Will any of those end up with fractional, decimal, or negative exponents? No. So this one is always, and this one is also always. What about a polynomial divided by a polynomial? 2x minus 3 over 4x squared plus 6. Is that a polynomial? No. It's not a polynomial because we're not allowed to have variables in the denominator. So it doesn't always work. Is it possible for a polynomial divided by a polynomial to be a polynomial? Well, if I had x minus 3 over x minus 3, that just simplifies down to 1. Does that satisfy the definition of a polynomial? Yeah, it does. None of the exponents on a variable are negative, fractions, or decimals. Okay, so that one is sometimes, and that is 11.1. Get to work.